So I noticed that I didn't finish this box here, so we need to go back to our last example. So we figured out that this was our diameter, and then we get a reflection of that circle when the radius is less than 0. So we reflect if A is less than 0. In other words, if it's negative. All right, now we're going to look at much more interesting polar graphs. All right, so this is the French letter Cedilla, I don't know exactly how to say it, but it creates this sort of weird sound. These are called limaçons, and you got to kind of, you got to have that little French little accent to it. But I'll explain more about what a limaçon is as we get into some of these. All right, so let's start off by, we want to look at 1 + 3 sine of theta. So our limaçons are always going to have A is less than B. If A is greater than B, I'll show you what they look like. It's not nearly as interesting as these. All right, so go to my calc. Clear this old bad boy out. 1 + 3 sine of theta again. And we get this cool little shape. So you get what we call, I don't know what they're actually called. I call them the big loop and the little loop. So this is my big loop, and then this is my little loop. A couple of characteristics as we look at this thing. So let's go to the sine. Let's change that to cosine. And here we go. There's our big loop, and there's our little loop again. So I'm going to go back over here. Just like what happened with circles, anything with a cosine is going to be on the x-axis, anything with the sine is going to be on the y-axis. I'm going to do the rest of a little bit more of this on the, I think on Desmos, I think will be easier to see. So let's switch over to Desmos. All right, so now my equation, 1 + 3 sine of, and remember you have to type the word theta to get the graph. And we get this pretty neat shape. Now, for those who are wondering what limaçon means in French, this is called a snail. You see the little snail? His little snail face. I wish I could draw little dots there and a little smiley face, but you get the idea that there's a little snail. So let's talk about big loop and little loop. So here's the little loop. Our little loop is a distance of 2. Our big loop is a distance of 4. Now we're looking at our equation and we're trying to make some connections between the big loops and the little loops. So if I go back here, let's say we change this to a 2 and a 3. All right, so what happened here? Now our big loop is a distance of 5 and our little loop is a distance of 1. Take a second, see if you can figure out what the pattern is. Maybe pause it, do some thinking. All right, hopefully you have a theory. So let's test that theory. What happens when I change this to, let's leave that as a 2 and change this to a 4. All right, so let's see if your theory was correct. My big loop is 6. Dun, 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 dun. My little loop is 2. Dun, 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 dun. And hopefully you figured out, yeah, the big loop is found by adding these two numbers together. And then the little loop is found by subtracting. And if you remember, we go back to our notes that B was always bigger than A. This is the A term, this is the B term. Since this is always bigger, when you subtract, you'll never get a negative. If it is negative, well, if it is bigger, you get this kind of, it's not very, if this is a 4 and this is a 2, kind of boring, right? It's not quite a circle. You can see that little flat part there. So I don't know what it's called, if there's a name for it. All right, so let's go back to our notes and add a little bit there about some of the characteristics of our limaçon. So we know that the big loop is B plus A, and I'm going to write it that order for a reason. And then our little loop is B subtract A. That's why I wanted to write, so that we could write, I want them to look in the same format. Remember, going back here, limaçon, say it with me. Oh. Limaçon means snail. And so we get our little snail shape. All right, so we want to now talk about the other intercepts. This is also something I think is easier to do on Desmos. Actually, let's just talk about both of them. Other intercepts and reflex. you're going to see that there's a lot of similar characteristics. So what's going to happen if so if we look at our other intercepts, so right now these are the intercepts that are figured out by our loop. These intercepts come from, well, let's see if you can figure it out. What happens when I change this to a 1? Our big loop, of course, is 5. Yep. Our little loop is 3, but how long is our other intercept? 1. If I change this to a 2, big loop 6, little loop 2, plus, minus, and then our other intercept is 2 as well. Let's say I leave that as a 2 and change this to a 3. Notice that didn't change our other intercept, but it did change our loops. So the other intercept, maybe you've already figured it out, is this value here. Whatever A is, that's going to be your other intercept. Blowing up over here. What happens when there's a negative? Take a guess. What do you think is going to happen when I make this a negative? Yep, you're right. It's just going to reflect it over the sign. So the term in the middle is going to determine whether or not your graph reflects. If you change the one out in front, it doesn't do anything. And why that is, I don't know. I couldn't tell you, but yeah, I'll just leave it at that. So let's go back and finish our little table here. So our other intercepts are going to occur whatever little a is. And then this is going to reflect if b is less than 0. So let's try to make a sketch here. We already graphed this on our calc, but let's see now if we can graph this on our own. So my intercepts are going to I always am going to hit 0. Every one of my graphs is going to go through 0. There are some that don't, but all the ones we look at will always going to have an x-intercept at the origin. So my origin is here. Am I going in the x direction or the y direction? Looks like I'm going in the y direction. My big loop is going to be an intercept of 4. 1, 2, 3, 4. My little loop is 3 minus 1. That's going to have intercepts of 2. And then my other intercept is going to be a, which is 1. All right, now I'm going to zoom in here. That b value is positive. All right, so how you want to graph this thing is you want to start at the origin and then just kind of nicely loop around. Don't pick up your pencil, just keep looping. You'll get something that looks like that. The one on Desmos obviously looked a lot better, but not too bad. Okay, let's do another one together, and then you can try that, or you can pause, and if you want to try it on your own, if you think you're ready. All right, let's take a look. So I'm going to start at the origin again. So my big loop, add them up. Don't worry about the sign here. That's going to do reflecting. All we do is add these two numbers together, the absolute value of them. 2 plus 3 is 5. We're going on the y-axis. So 5 on the 1, 2, 3, 4, 5. Subtract them, that's a 1. Dang it, I messed up. Because it's negative, I need to do that in the negative direction. So I'm going to put little x's on those guys. And I'm going to go the other direction. 1, 2, 3, 4, negative 5. 1, 2. 2. Dang it, I messed up again. 1. I'll highlight this in a different color so you can actually see what my crappy graph is supposed to look like. And then my other intercepts, that's the a value, so that's a 2. That's a 2. All right, so start at the origin and try to do your loop-de-loops. So I'm going to go big loop, and then small loop, back to the origin. Ignoring all those terrible blue x's, let's see how I did. All right, so 2 minus 3 sine of theta. 2 minus 3 sine of theta. 2 minus 3 sine of theta. Shazam. Boy, not very, whatever, you get the idea. Okay. So I'm going to have you pause. You try to do the next one on your own. And then, well, yeah, I'll give you a second. Okay, let's see how you did. so I'm on the x-axis. I'll try this one in blue again, see if I have more luck with blue. I'm on the x-axis. I'm not reflecting. My big loop is going to be 6, so 1, 2, 0, 0. 1, 2, 3, 4, 5, 6. Subtract them. 4 minus 2 is 2. There's my little loop. Number out front is a 2. 1, 2. 1, 2. All right, now I want to try to connect this all with the loop-de-loop. So start at the origin, loop to your big, loop back around. Ooh, that one was pretty good. Let's see how we did. Just a quick double check to make sure that we did it right. 2 plus 4 cosine of theta. Nice. All right, pause again. Now this time you're going to play with your calculator. You're going to try to type in an equation here that gives you the picture here. So you're going to try to put in an equation that you want, or on Desmos, try to generate this picture. All right, hopefully you gave that a try. Let's see how we did. Go back to, let's do a brown one here. Nah, brown's too hard to see. All right, so first of all, my big loop, 1, 2, 3, 4, 5, 6. My little loop, 1, 2, 3, 4. So I need to find two numbers that add to make 6 and subtract to make 4. I think I've got them already. But a nice hint here is remembering that you have these other intercepts. And whatever your other intercept is, that's automatically your first number. So my first number, my other intercept is a distance of 1. Okay, 1, first of all, we're going negative or positive. This is going negative. All right, my big loop was 6. My little loop was 4. So what number could I add / subtract with 1 and get 4 and 6? That gives us our 5. We're on the x-axis, so this is going to be cosine. And then don't forget your actual variable, which is theta. Okay, I ran out of time again, so I'm going to have to pause and move on to the next part in another video.